So I did want to just talk about, we've, in the last series of videos, talked about what if x is in the base in terms of using the power rule, and what if x is in the exponent in terms of exponentials. But what if x is in both? So if x is in both the base and the exponent, what do we do? I cannot use power rule because I have x in the exponent. I cannot treat it like an exponential because x is in the base. Uh, Both of those rules require a constant somewhere, and I don't have any constants here. So what we do with this is we say, okay, let's make it so, let's redo this so that it's not x in the base and in the exponent. Because we have to remember, we have the tool of implicit differentiation. We don't have to have y isolated. So what we're going to do is we're going to take the natural log of both sides of this equation. So I now have the natural log of y is equal to natural log of x to the x. And I've got x to the x graphed on the right here in case you're interested in what does that look like. I can now do a property of logarithms, the power property, and pull that x that's in the exponent out in front. And this has now become an implicit differentiation problem where I'm doing a product rule. So x is my independent variable. So anything that is not an x is going to require chain rule. So the derivative of natural log of y is 1 over y times whatever dy dx is. I don't know what it is yet, but I do know I need it there. And then for x times natural log of x, I need to use the product rule. So I have first times derivative of second plus the second times the derivative of the first. I need now to isolate dy dx, so I'm going to multiply both sides by y. Well, x times 1 over x is 1, and then the natural log of x times 1 is just natural log of x. But I know from up here what y is, so I'm going to replace the y with x to the x, and there is my derivative. You don't need to memorize that that's the derivative of x to the x, but if you are stuck in saying, I'm not sure what rule to do here because I have x both in the base and in the exponent, you're just going to take the natural log of both sides so that you can do the power property of logarithms and then do implicit differentiation.